As I said, we'll start on page 128. Before we do, a quick look at the calendar. We got some stuff happening this week that's kind of important. Here we are. So today we are going to cover, it says 2.1 to 2.3 and 2.4, which is technically 4 sections, but really 2.1, 2.2, and 2.3 are all very short, and that's one lesson according to the schedule that we've made. So we're actually going to cover 2 different lessons today. And next class we have our review for the first half of class and then our quiz for the second half of class. And I will say that this 2.1 to 2.3 is on the quiz, but 2.4 is not. So how are you supposed to know that? So if you look at your green homework page, currently we've been working on assignment 4, and like I said, I'll check whatever homework you have today. But 2.1, 2.2, and 2.3 is in this box, which means it's fair game for quiz number 2. But down here, section 2.4 is not due next time, okay? And again, if you're looking at the schedule, it says that right here, 2.1 to 2.3, which is one section, is due next time, but 2.4 isn't due until next week, okay? Any questions on the calendar? All right, and just a heads up, why is there a big gap between March 13 and March 25? Spring break. All right, I'm gonna miss you guys. Okay, so that's the calendar, and I think that's that. All right, so let's take a look on page 128. Just our standard reminder, we have a quiz coming up, and there's a whole long list of resources that you can use to prepare for that quiz, including the yellow 2. Have I handed out yellow 2? Crystal and Megan, could you guys do me a favor and just put about 3 or 4 of those on each table? Thank you. Okay, so you will find practice problems for quiz 2 in this yellow thing that's going around. Okay, one other reminder about the quiz. So this might be something some of you will take advantage of. I mentioned that our quiz is coming up on Thursday, but everybody in every section that Sandy or I are teaching is welcome to take the quiz with any other section. So in particular, if you are interested in taking the quiz a little bit later in the day on Thursday, then you could take it with Sandy at 11 or at 12:30. Or if you really want some more time and it fits your schedule, I will point out that the quiz for the Monday, Wednesday, Friday classes isn't until Monday. So instead of taking the quiz this Thursday, if you want like 4 extra days and you happen to be free on Monday the 10th, you could come in and take it with Sandy at either 10 or 11, okay? So this, yeah, 10 or 11. This is on your blue schedule. It's just the other side. We've been focusing on the Tuesday, Thursday side, but you're welcome to take the quiz with anybody at all, me or Sandy. Any questions on that? Okay, so let's jump in here with the objective here on page 128. Okay, who's ready? Nicole, can you read the objective, please? Inequalities, thank you. Okay, so we'll first start by talking about the meaning and the notation we use for absolute value. It's the first time we have seen that phrase in this class, and we bring it into this class because it's going to be relevant to solving certain kinds of equations very soon. But for right now, all I'm interested in knowing is, for example, what is the absolute value of -3, and separately the absolute value of 2. So what is the absolute value of -3? It's 3. So I'm just going to put an equal sign here and the number 3. What's the absolute value of 2? Is it -2? It's 2. Okay, so first the notation. If you see the vertical bars on either side of a number, that's our way of saying do whatever we just magically did. So can somebody give us an explanation in English for what's going on here? How do we know that absolute value of -3 is 3, but 2 just stays 2? -3 is -3 of something. So what do you say? So how do we find the absolute value of a number then? Okay. Make it positive. Okay, so write down what we heard. So we find the absolute value by counting, or as Annika says, make it positive. Other thoughts on absolute value? So is this something that we all know how to do? Okay, so let's go with this make it positive idea. If you have a negative number and you want its absolute value, you just make it positive. So it's like ignore that negative sign. It's a strange thing to do, but this is what we do. And what if the number is already positive? Then it just stays the same. So those are the two rules. If the number is positive, you just copy it down. If the number is negative, you make it positive. Can somebody give us a reason? And I think this is actually what Eric was kind of getting at, this counting thing. But what is it that we're really doing when we say the absolute value of a number? What are we really calculating? Yeah, it has to do with the number line. So let's draw our friend the number line here. So 0, 1, and 2, -1, -2, and -3. Remember that time I completely reversed the order on the number line? Gosh, was that embarrassing. I shared it with Sandy, my colleague. I showed her the video. It was one of my lowlights. Okay, so what are we finding? So I see -3 there on the left. What is it that, what question is 3 the answer to? Distance from 0. That's it right there. So if we're looking at this dot right, let's make that red. If we're looking at that dot at -3, and we are counting or finding out how far it is from 0, the distance from 0, well, how far is that? It's 3. And if we want the absolute value of 2, we're finding how far 2 is from 0, and how far is 2 from 0? It's 2. And so just by virtue of us asking a how far question, of course the answer is going to be positive, and that's all that we're doing. So we can just say, we're just finding how far is the number from 0. Okay, we will come back together in maybe a minute and a half. In the meantime, with your neighbors, can you try to fill in A through F here? No calculators. Sure. Okay, so what do we say? First one I think is the easiest one. What is that? That's 6. The second one, we got to now start thinking about order. The absolute value of 6 is the first thing you do, and I'll just make a note over here. Absolute value is like parentheses in terms of order. And we know that parentheses always tell us to do what's in there first, right? It's like a priority. Absolute value is just like I said, a parentheses. You got to do what's in there first. So the absolute value of plain old 6 is 6, and then there's a negative sign just waiting to change your answer at the end, okay? And then in this next one, again, I'm going to copy the negative sign in the front, and then I'm going to write down what's the absolute value of -6? It's 6. So this is the answer. And I bet a couple of folks in here looked at this and said, oh, 2 negatives make a positive. And maybe the answer is just +6. And 2 negatives do make a positive in part D, right? Because this is just saying take the opposite of -6. And what is that equal to? That's 6. And yes, 2 negatives make a positive in some contexts, but apparently not in the context of absolute value. So we got to make sure we're not applying old rules to this new absolute value idea. Okay, it is very easy to get E and F wrong. What do we do first in part E? Do we do this calculation in here, or do we make both these numbers positive first? A few folks say both, make them both positive first. What's that? That says do the calculation. Remember, absolute value is like parentheses, which means you got to do what's all in the absolute value before you actually figure out the absolute value. So we need to do this calculation, which means the absolute value is sitting here waiting for us to find out how much -7 plus 3 is, which is -4, okay? Absolute value comes at the end there. And then the final answer is +4. But the answer to this one is definitely not 10. No matter how tempting it is to say, oh, I just have to take positive 7 and positive 3. That's not how absolute value works. I find the number inside first. But in part F, what am I asking you to do first? A calculation or absolute values? Absolute values, right? Yeah. So we do what's in the parentheses first. So what's the absolute value of negative 7? Is 7. Plus, what's the absolute value of 3? It's 3. So this one is 10. It's really easy to get those two, to say they're both 10. The first one is 4. Questions on any of that? And it's okay to get some of these wrong because often the way you get them wrong is to apply a familiar rule in this unfamiliar context. And so these examples are just supposed to cue us in to what like the new rules are for these guys right here. Okay, let's take a look at number 3. Discussion of the meaning x is greater than negative 3. I'm just going to make a real quick list. Here are some x's that make, all right, so first this guy is called an inequality as opposed to an equality with an equal sign that make the inequality true. Just gonna make a quick list. And then some x's and all that stuff, but make it false. So we're just gonna list a few numbers in each category. So can somebody give me a value of x where x is greater than or equal to negative 3? 0. You guys agree that 0 is bigger than or equal to negative 3? Super. Somebody give me another number. X equals 1. Do we agree? X equals 1 is bigger than or equal to negative 3. Wonderful. Negative 2. It's still bigger than or equal to negative 3. I'm going to push the limits here. What about negative 2.994? Is that bigger than or equal to negative 3? Yes, it is. It is slightly bigger than negative 3. How about negative 3 itself? Why is it a yes? Yeah, because we have been saying, so here's the way that we say this sentence. I've been saying it, but that symbol right there is greater than or equal to. And negative 3 just snuck into that category there. It's the equal to part, right? It's just barely makes it true, but it still makes it true. How about negative 4? Doesn't make it true because negative 4 is on the other side. So x equals negative 4 makes the thing false. X equals negative 100 is definitely not greater than or equal to negative 3. It's smaller. What about negative 3.1? It's just a little bit smaller, so it's not bigger than or equal to. Okay, and so if I wanted to, I could maybe think about graphing all of the answers, because how many different answers are there that make the inequality true? I see 5 here, but really how many are there altogether? There's infinitely many numbers that we could have listed here. How many make it false? Infinitely many. So what we need to do is think about a way to save some time and write them all down, but not actually write them all down forever. So here's my number line. And what we're going to do is shade in all the numbers that make it true. So roughly speaking, the numbers that made it true, are they on the left or the right? Think about this list of numbers over here. This list of numbers is out there to the right. And the ones that didn't work, like negative 100, are out there to the left. But where's the cutoff? The last number that works is negative 3. So I'm going to put an open circle for just a moment. Open circle is our way of saying this number does not work. So is that correct or is that wrong? It's wrong, because we said negative 3 does work. So how do I indicate that negative 3 does work? Is I fill in the circle. And then all we're going to do is shade in the line in the correct direction. Did we say the numbers that worked were on the left or the right? It's to the right. So we're just going to shade in. And I just want to highlight that I'm doing this a few times. I do this a lot of times because often what students do is they make this teeny tiny light pencil line on the very thick computer generated line on the test, and I have no idea where the line is. I can't see anything. So go back and forth, and then we'll put an arrow out here to the right so it is very clear to the reader. Yes, I would really like to see this line. Okay. Okay, and the other thing is some students are taught to do this, but to do it above the line so that you can see it. I don't like that. The number line is there. There's nothing floating above the line. So if you've been taught that, I'd appreciate it if you wouldn't do that for me. I'm giving you a number line. Draw in on it very dramatically, very boldly so that I can see it. Okay, so in terms of knowing which symbol is which, because that's a greater than symbol, and there's another symbol that goes the other direction. It's a less than or equal to. Some people think about like, like that's the mouth of an alligator and it eats the bigger number, or there's a lot of different ways to think about what the symbol means. And it doesn't matter to me how you think about it. Just whatever way works, or come up with some way that works, and get to the point where you can actually start shading some stuff in. So what I'd like for each group to do is 2 of these problems. What you're going to do is graph the solutions. Actually, each one will put 1 solution up here, but we're going to ask everybody to do all of them for the next couple of minutes. But I'm just going to call on somebody at each table to maybe shade in the answers for each of these things here. Okay, so everybody start working through here, and then we'll get our answers up on the board. Okay, starting in part A, this symbol right here, you kind of need to know how to say it out loud, just because how you say it completely dictates what it means. Is that a greater than or a less than symbol? That's a less than symbol. All right, so this says x is less than 1. So we start at 1 with an open circle, with an empty circle. So we should start at 1. All right, so let's add. No problem. So 1 here, and then all this stuff. So it is clearly shaded with all the numbers less than 1, and 1 is not included because it doesn't have that little equal symbol there. Okay. All right. The next one is part B. That symbol right there, is it a less than or a greater than? That's a greater than symbol, so definitely going to shade in the numbers bigger than -2. So start at -2 and then shade all the way to the right. Why is this an empty circle? There's no equal added to that sign. Okay, the next one is it's really easy to get this one wrong. Let's take a look. This says 4, and then what's that symbol? Is that less or greater? Yeah, so this is greater than or equal to x. All right, so 4 is the first number, the starting number. And does 4 get filled in, or is 4 empty? 4 gets filled in because of the equal sign. So I'm just going to really highlight that this is filled in right there at 4. Now this symbol is kind of written in a funny way. This says 4 is greater than or equal to x. But generally our frame of reference is thinking about how x relates to the magic number. So for me, I really have a hard time reading 4 is greater than x. I need to read it right to left, which is a little bit backwards, because I need to focus on x. So if I read this inequality that way, it says x is what compared to 4? X is less than or equal to 4. Right? This says x is less than or equal to 4 if you read it the opposite direction. And so this is correct. These are all the numbers less than or equal to 4. But it's really easy to look at a greater than symbol and just think every time I see a greater than symbol, I'm shading into the right. And it's just simply not true. You really have to pay attention to where the x is. Okay, down here, same thing. This one is kind of backwards from my perspective. If I read this guy this way, then it says x is what? Greater than -2. So we start at -2 and shade all the ones that are bigger. That's perfect. The next one, x is greater than or equal to 3, filled in circle at 3, and then everybody greater than 3. And the last one, so this guy right here again is written in the backwards way. So read this one this way. X is what? Greater than or equal to 3. So this is not shaded correctly. Right? Yeah, E and F say exactly the same thing. We've just written them like in reverse order. So we're going to change the direction of this arrow. Okay. Questions on F? Cole or Megan? Somebody just had a question. Is E backwards? F? Yeah. So F says that 3 is less than or equal to X. But for me, my perspective always has to be thinking about X first. So if I read this thing from right to left, then it says X, and then from this perspective, it says X is greater than or equal to 3, if you read it the other direction. So we start at the number 3, and we shade in all the X's that are bigger than 3, which is all those numbers to the right of 3. Holly? Absolutely. Nope. Completely feel free to rewrite it in. Yeah, totally fine. Okay, so that's how we graph some inequalities. Next thing we're going to do is on the next page. So let's read through some of the directions to this puzzle here. So the first bullet, here's the puzzle. You're going to fill in all of these boxes. I guess there are 10 of them there. It says you fill in each box with either a positive sign or a negative sign. And it says fractions connected by equal signs should be equal. So in that first row, you're going to come up with 3 different ways to write equal fractions. And in the second row, you're going to come up with 3 different ways to write equal fractions. But then the last thing is that no 2 of the 6 fractions should look the same. So you can't just fill in plus signs on everything because then they all look the same. So with your neighbors, see if you can come up with ways to fill in pluses and minuses. Okay, let's come back together after this puzzle. I think the groups have made good progress. Ultimately, what you have remembered is that if you take, for example, a positive and divide it by a negative, what kind of an answer do you get? Negative. And what's the other way to get a negative? Minus and a plus. So that's how we can get a negative. What are the ways that you can divide 2 numbers and get a positive? 2 negatives or 2 positives. So that's all this is saying. And I just want to highlight that in this top row for me, if you see so I'll write it without the boxes here, but if you see the fraction 1 over negative 2, or I'll write the last fraction for me, negative 1 over positive 2, you can change either of them into the more common negative in front of the whole thing. Okay? This is the idea, is that if you see a negative on the top or on the bottom, it doesn't make any difference where that negative is. It's the same answer at the end. And typically you just make the whole fraction negative, negative 1/2 in this case. So as a class, let's jump down here to this full class thing. It says which of the following are equal to each other. So let's go ahead and circle all the ones that are equal to this first answer here. So this is a positive 1/2. Are there any other fractions in that list that are equal to positive 1/2? C. Because we know 2 negatives divided make a positive. Any others equal to positive 1/2? Is E? No. Okay, so then I'm going to put a rectangle around the part B answer here. Are there any other fractions equal to that one? D. Any others? And also E. Good. Okay. This is why they pay me the big bucks, Heather. Okay, so let's have you guys do some group stuff. We do have another topic to cover today, but I want to spend like the next 7 or 8 minutes. Skip over that page we just looked at and jump to number 2. And see if you can, all right, I'm going to be really selective here because I want us to get to a certain place. So here's what I'm going to ask you guys to do. 2A and B. And you're going to skip over number 3. You're going to read number 4. It's just factual information for you. And then you are going to do as many parts on the next page until I say stop, okay? I'll put the flags out, raise them if I can help. Okay, so the first thing on 138 is a reminder about some heads up. So I'm just going to remind you of something that we said about a month ago, is that we have done our best to keep negative numbers out of all of the algebra. And we've been holding off for about a month, doing lots of algebra with only positive numbers. Now we bring negative numbers in, and essentially we do the same kinds of things we've been doing for the last month, but now negative numbers enter the picture. So if you have difficulties with negative numbers, it is time to take action, and take action soon, because you're going to flail around, maybe not because you're struggling with the algebra, but because you're struggling with the arithmetic of negative numbers. There are resources for you to practice with those negatives, and you got to get there soon because we are starting negatives right now. Okay, so let's go to the objective here. Can we go to Meg in the corner? Can you read the objective, please? Great. So what we're going to do is graph this equation, y equals -2 minus 3x. And for the first time, we're going to make a table that includes some negative x values. It's not a big deal. It's the same idea as the tables we've been making. But first, we got to fill in the first column with a y and an x in some order. Which one goes first? It's x, right? We know that x is the first thing in a chart and y is the second thing. And now we're going to pick a few positive values of x. So for example, I can pick x equals 1, and I can pick x equals 2 and x equals 4, just making up some positive numbers. But now for the first time, we're going to throw some negative values of x into this table. So can somebody give me 2 of these negative numbers to plug in? -2 and -5. So let's fill this table in. Again, the formula that we are using is this -2 minus 3x. And so we'll plug in x equals 1 into that thing. So x equals 1 tells me that y is equal to -2 minus 3 times 1, right? X becomes 1. And that equals okay, wait a second. So which do we do first, the subtraction or the multiplication? Multiplication. So I'm going to copy the -2 and the subtraction, waiting for me to do the multiply. What's 3 times 1? 3. And now we do the subtraction, and this is -5. There are a lot of other numbers that we might get besides -5. If we get any of other number besides -5, it means we need to practice with our negative numbers. Again, what we're doing here is not new, except for the fact that negative numbers are going to be in all of our problems now. So if you need to work on negative numbers, time is of the essence. Just a reminder, this topic is not on the quiz, right? We just finished what was coming up on Thursday's quiz. Okay, so that -5, I guess we can put right in there. And so with your neighbors, very carefully calculate the rest of those y values, plot 5 points, and hopefully draw a straight line.